Yes, thank you.
Oh, look, someone's turned the egg timer for us. Okay, good morning, everyone.
Good morning.
It's the last day.
Yes.
I hope everyone is full of information. I know I am. I'm Stuart Preston.
I'm Gael.
Okay, we're going to talk about our topic, which is test-driven infrastructure with Test Kitchen, Chef, and DSC. Gael is going to do an introduction. And I'm going to talk about some of the tools Chef created around this. Gael's going to talk about some of the work that he's been doing with DSC on it, and then we'll have time for questions as we go.
So the first thing is, who's using Chef? Just before we start that, who's using Chef? Who's using DSC? Well, yes. Who believes Test Kitchen is only for Chef? Great, you know already a lot about it. So the key is, whether you're using Chef, DSC, Puppet, SaltStack, or something else, the principle remains the same. And this is the debugging cycles that should be driving every change that you're making to your infrastructure. The idea is you need small iterations on respecting always this process, which is the PDCA cycle, which is plan, do, check, act. I'm not going to go in details, but this is the reference. And this is, I think, what Jeffrey talked about, the first key to DevOps is small batches often, right? And this is the process you need to follow for those. And I really like the way Dave Thomas actually summarized this. He says, find out where you are, take a small step towards your goal, adjust your understanding, and based on what you learned, that means you need to look back, and you need to see what you've learned from what you planned and what you actually achieved, and then you repeat this over and over again. Pretty simple. So how does that fit into an infrastructure management in general? So everyone should be, by the end of this, at least this conference, what a module pipeline is. You write some code, you put that into the pipeline, that creates your artifact. You put that artifact into an artifact repository, the PS gallery, for instance, and then you can reuse this as much as you want. And that never changes. If you want to change your code initially, it goes against it within the pipeline, creates a new version of it, so a new version artifact, which is immutable. You don't change it. You build trust over time with it because it runs your tests. And you can reuse that module over and over again from the gallery or an internal gallery. This is what a pipeline looks like for a module, just a reminder. And the key is it follows the pipeline model where you have your source in Git or source control in general. Then you build it, you test it. You maybe have a gate to see, well, am I happy to release that into production? Am I happy to release that to the PowerShell gallery or the artifact repository? And then you can release it to the gallery towards the end. What's important in there is also the feedback loop at the top. Every time it goes from one stage to another, you have an opportunity to learn about it. So you can get some feedback out of it and say, well, is it doing what I believe it's doing? And that gets back to what we've seen with the first diagram, where you need to over and over again make sure that you delivered what you believe you delivered. So when you have your module pipeline, you actually have pretty much one for each module. Every time you change some source files, it goes through the pipeline, create a module that you trust because it's already been tested in the pipeline, and you put that into the gallery. So you can have, for DSC, it would be some DSC resources, it would be some modules, it would be some DSC composite configurations, for instance, and then they end up into the gallery, and you can reuse them into your infrastructure pipeline.
All right. The reality is software sort of behaves differently on different platforms. So Windows 7 versus Windows 10, we've got different prerequisites, different things installed by default on those environments. Windows Server versus Linux, obviously. We have to deal with differences in how we deal with paths. And then there's differences in Debian and CentOS. You can't just trust that the thing you've written for these platforms behaves the same on all of these environments. So we really need to test the application or the payload we're working with across those multiple platforms. And to do that, we need to test the desired state of the application to check we have the correct result. We express those tests in code and use tools to execute the tests, which is kind of leading on to how Chef came to build Test Kitchen. So Chef built Test Kitchen to test parts of Chef. So the payload for Chef is a cookbook, and that's where all of the content for delivering an application using Chef lives. But of course, people want to test a cookbook across multiple platforms. So we open sourced this tool Test Kitchen in 2014, and we added Windows support in 2015, roughly. We've been lucky enough to have contributions from Puppet, Ansible. I think Salt have made some contributions as well. We applied a configuration through code. So there's a code file that is driving the configuration. And the important thing about Test Kitchen is we're looking for a clean room environment every execution. So we don't want one execution to follow another and inherit something bad that the previous execution did. And Test Kitchen really helps us transport those tests from the workstation we're working with to a target machine so that we can execute those tests and get a result. So I'm going to probably drop straight into demo at this point. So here's my repo. Let's pop up code. I'm going to find a basic cookbook that I started to install PowerShell from the releases section of GitHub, PowerShell core. So this is a cookbook payload. It's just a folder structure. Cookbooks, as I think some of you were there in earlier sessions this week, cookbooks have recipes. Recipes contain resources. Those resources get executed via a Chef client. The Chef client executes a recipe in two phases. It compiles the recipe and then executes the result of the resource list that it creates afterwards. And so this particular cookbook, we start with default. My default recipe just includes a kind of a top level. It's kind of just a general thing that we do in cookbooks. And then I've got a simple case statement here. So Chef clients are kind of aware of their platform, so you can do things like simple case statements to say, well, okay, if we're on Ubuntu or Debian, I'm going to run the install deb recipe. If we're on CentOS or Red Hat, then install via RPM. If you're on Windows, call the install Windows recipe. It's pretty simple stuff. There are more clever ways of doing it, but I just wanted to put that in there. This is the recipe to install on Debian. It just kind of formulates the install URL based on this thing called an attribute. So we have a default attribute here. I've just created a default attribute, pwsh installer version 6.1.0. And we just interpolated that into this string. Then the resources we need, these are built-in Chef resources in core. There's no external cookbooks or anything. Remote file, which is just pulling down the install URL and saving it to the installer path. Apt package, which runs the apt package manager and installs all these kind of prerequisites that we still need if you're running dpkg on Debian. You still need to do this. If you're running it from the repository, the official Microsoft repository, and running dpkg against the Microsoft repository, all of these dependencies should get resolved for you. And then we run dpkg on the installer path. And then the RPM is similar, except we're using the yum package manager. which means we probably don't have to deal with those dependencies. And then the Windows one, strangely enough, is pointing at the MSI. And so this is the cookbook. And of course, the test we want to run at the end of this is stored in a test folder. We can create test suites of these. I've just created one test in here using Chef's tool, which is inspec. And inspec allows us to, inspec has a set of resources. One resource within inspec is the command resource. So this is the simple description of, I'm just going to run pwsh -- version, expect it to exit 0, and expect in the output somewhere to read 610. So that's fine with the cookbook, but now how do I go and test this on different platforms? Well, I need to use the tool we created for it, which is Test Kitchen, which is why you often hear me say Test Kitchen is our development tool for Chef. And that's driven by this file called kitchen YAML. And in the kitchen YAML, we have there are 4 key elements, sort of driver, provisioner, verifier, and platforms, and then the thing you're testing, which are called suites. So in the driver section, we're using Vagrant. So is anyone using Vagrant in the room or heard of Vagrant? Okay, so that's a good sort of proportion of you. So Test Kitchen, we wrote a driver that integrates with Vagrant, and we now added Hyper-V support to it recently, so we can run this completely on Windows.
You mean Vagrant Hyper-V?
Vagrant Hyper-V.
Because there's also an Hyper-V driver.
There is also a Hyper-V driver, which just allows you to interact solely with Hyper-V. But the purpose of Vagrant is to sort of provide an abstraction over the different types of providers. So you could switch Hyper-V for VirtualBox. So Vagrant's payload is a box file, and so we need some boxes to run on. We actually at Chef publish these boxes. If you go to Vagrant's up, it's just boxes. And search for bento. These are boxes we publish, and they cover the majority of sort of Hyper-V, Parallels, VirtualBox, VMware Desktop, etc. And we need the reference to each of these boxes. We put them in our platform section within the kitchen YAML. So I've got a platform here, one for Ubuntu, one for CentOS 7.4. I've put a 2019 thing in here because I've been playing with Packer, which is the tool you use to create those boxes and upload them. But I'll leave the Windows side of it out for demo purposes. We have this thing called a provisioner. So when Kitchen starts up one of these machines, the machine is not going to have Chef running on it. But the thing is, we need Chef running to test our cookbook because we're executing the cookbook on that machine. So the provisioner's job is to connect to the machine we started up. It's going to test whether Chef client's installed. If it's not installed, it will go and pull down the Chef clients and install it. And we can specify which particular version of Chef we want installed. I put here we want Chef 14, but you can force your target machines to have a specific version installed. Our verifier is inspec, as I mentioned. If I go here, inspec is our tool for compliance testing. We use it for a combination of things. We use it for compliance, and we use it for integration testing on our cookbooks.
It's a bit like OVF or Pesta, but more advanced, and it's been in development for longer, I think.
Yeah, there's sort of many aspects to inspec, one of which is that we have a complete set of CIS profiles that you can download and just execute the whole lot on a machine, and we maintain those. So down the bottom, I've got my thing called a run list, and the run list in Chef is the list of recipes in order you want to execute on the machine. I've only got one, so it's namespaced, so PWSH is the name of my cookbook. PWSH was the name of the recipe, that was my entry point. And then it says to run the inspect tests under test integration default, which is conveniently where they are on my machine. So within Kitchen, there are 4 commands, plus a few others. Kitchen list gives you the permutations of your test suites and the machines. If I had multiple test suites and multiple machines in here, they would matrix together and you would see all the combinations of your run lists and all the combinations of your machines. So you could test every permutation. So we see here I've got 2 instances to create, one on Ubuntu, one on CentOS. And the first command, so you can run kitchen test, which covers the whole test suite through the creation, the converge, which is the bit where Chef Client is installed and running on the machine, the verify, which is where the tests run, and the destroy, which is where we sort of tear down things at the end. But I'm going to sort of just run them each individually. So I've just got 2 instances here. Kitchen create, Kitchen itself is installed from our Chef development kit, or if you've just got Ruby, you can just gem install test kitchen. What it's doing here is it created a vagrant file for each of these platforms that I'm testing, and basically called vagrants up on that. It started up virtual machine in Hyper-V, and then it's kind of waiting for the IP address, and then once it's got the IP address to connect to, that's it. We're done with the create phase. In this case, I left it as the defaults. So the boxes that get installed onto Vagrant site that are pulled down to your machine, if you don't have them, I have them cached on this machine. If you didn't have them cached, it would have downloaded the box file from the Vagrant site automatically. Goes in and replaces the private key with one that's generated. So in the blue, that should have done the Ubuntu. And then it waits to establish a connection to it to say, yes, I'm successful, and then ordinarily it would have moved on to the next phase. Now it's starting up a CentOS machine, again on via my Hyper-V. And you can run these in parallel, but the reality is that with the type of cookbook testing, which is kind of our payload, you wouldn't necessarily want to do that in parallel. You'd just, it'd be part of some longer CI process. It'd be something you run kind of, through your CI system, through Jenkins. We've got integrations with VSTS that we've written and are available on the marketplace, etc. So hopefully, you see this machine's starting up. And watch it boot up. Then we can come on to the converge phase. So it's probably just waiting here for 30 seconds. But pretty much as soon as this machine comes up, as you see, we're running some PowerShell in the background just to query Hyper-V to return the IP address for the machine until we actually get a valid IP address. And luckily with the default switch in the latest Windows 10, it kind of behaves pretty much exactly how you want it as a workstation. If you're doing cookbook development, we're now in a pretty good place with doing that on Windows with Hyper-V, because the default switch behaves like an internal switch. If you're not connected to any network, you can still connect to it. and it behaves like a switch that provides a NAT capability if you're on a wireless. Yes? This is just the latest non-insiders build. This is all public bits.
So within the YAML file, you can define anywhere which virtual switch you can use. So you can just be more specific if you set up one specific switch.
Yeah, we did this at the top. You can customize the Vagrant capabilities here. So if you want to put more CPUs or memory on particular machines, you can also move these sections inherit from each other all the way down. So you can put any driver section underneath any other named platform to override something that's at the top. So, for example, we need both to support both WinRM and SSH. Transport name is SSH at the top, and then we override it just for our Windows 2019 box to supply WinRM as a property further down, and that gets resolved out. Now it's done the thing with the key, so we should be ready to converge, it says. There we go. In fact, what I'm going to do is just stop that and just do a kitchen converge. You can specify one or more machines to converge at a time. I'm just going to converge one of them rather than make you wait through all the permutations. So if you type kitchen converge Ubuntu, it's just a regex, and it will match it will match the first thing that matches. So kitchen converge will now start kitchen. It should start an SSH connection to the machine. Of course, I'm at the mercy of guest wireless. Just make sure I am on the right wireless.
So the process is, the first thing you do, you spin up the VMs. The second step, you converge. And this is why Chef, Puppet, DSC is a convergent-driven infrastructure. So you have a definition of the state, and you say converge to that state, and the system, the DSC resource or the cookbooks, actually apply that to in an independent way, and they just converge to that state. So if it's finished and successful, it tells you, I'm in the state you expect.
Yeah.
And when you use a pool mode, you eventually converge. That means you make the configuration change available, and then you eventually converge. That's the same thing, I believe, in pretty much all of those three.
Yes, so we used the Chef provisioner here to pick up all the files from the cookbook, and we transferred those. At this point, we're preparing the files for transfer. This is the bit where it's testing whether the machine has the right version of Chef on and goes and installs it. It's basically running the package manager against the right version of Chef for that platform. And we support kind of a myriad of platforms at Chef, so this is kind of as much a test of our infrastructure around platform detection of it as anything. Now the files have been transferred, my cookbook file. It's running the Chef client with the run list that I specified in my kitchen YAML. And we can see it says it's converging through resources, and we're in the install deb recipe here. So it's pulled down that remote file, which it copied into temp. It's now running, should be running the apt install on the dependencies, and then it will run the package manager again to get things installed. Of course, the next piece of the puzzle here is we want to run the verification step.
So that if you remember one of the first diagrams I showed, you want to use your pipeline to trust the changes you're making. So that's why you make a change, and you make sure that even if the system tells you that it converged to that state, that it actually does what you believe. This is the same principle as the operation validation framework, or what inspect does, and this is what you're going to run just next.
Yeah, I mean, at Chef we run this on our CI system against every cookbook that people upload to our supermarket. Behind the scenes, we're running Kitchen. We've got a whole list of platforms, and we give people the feedback to say, okay, this cookbook doesn't execute or doesn't compile when you're on Solaris or AIX or whatever platforms we've got in our test matrix at Chef before we can accept it as a Chef cookbook. That's just a process that we go through to make sure that cookbooks are valid for our supermarket. So if I run Kitchen Verify, this is basically triggering inspect behind the scenes. Inspect runs on the workstation and remotely connects to the machine over SSH, and then remotely is executing the resources of inspect against that machine. We should see the outcome of my recipe, which is hopefully positive, and if it's not, we need to go and fix it. And so there's different sort of styles of development. So test-driven infrastructure is not necessarily, oh, nice, yeah. Okay, so it's carrying on because I didn't specify a platform here. But you see the output is command pwsh version. We've got 2 test passes. And that would like exit 0 if we were in a CI system.
So it's good to explain what happens. So because the first time you specify the Ubuntu to converge, but not the other one, so I believe now it's reconverging it. Is that correct?
No, what's happening is the Ubuntu is always in blue here. So it verified Ubuntu, but then because I didn't specify the CentOS, it's gone ahead and gone, right, what haven't I done to the other platform? And the answer was it hasn't converged the other platform, because it obviously needs to converge the other platform before it verifies. So it's carried on and done that, but we'll...
In terms of the workload, this is very useful. So then you make a change and you're trying to get your configurations right. And then you can tweak it on only one machine until you believe everything's going to work. And then you can just converge everywhere to make sure that your change works on every platform that you have.
Yeah. When you're in development mode, it's pretty useful as a development tool because you're working locally, you've got multiple platforms, you're potentially writing recipes that behave differently on different platforms. You do not have to tear down that machine and have a clean room every time if you're just making kind of minor changes in your, whilst you're developing. You can basically keep rerunning the converge and the verify to put the new changes from your cookbook onto the target machine and then re-verify. So let's let this CentOS machine sort of finish. I think we're pretty much in the same place. So in this case, you see it installed. The logic said install, took us down the route of installing the RPM. Which it should be doing. It's installed that. Now it's running the verify. Because the exit state is 0. If you rerun verify, you can rerun it continuously, then it'll test across all the platforms. Yes? Yes, so with our Chef provisioner, we provide you a set of environment variables that can be transferred to the machine and set up on the target machine before you actually run the Chef client. So if you have like the need for an HTTP proxy and an HTTP proxy port variable to get to your proxy, we support transferring that within Test Kitchen itself. So you can see here we just rerun verify as many times as we want. And once we're done, as would be in a CI system, we can type kitchen destroy, and that's going to tear down both of those machines. And we should see them drop off our Hyper-V. Yes. I mean, we specify. You can specify the memory. I mean, Linux boxes don't need enough. I've put a gig for each box here, but you can override that setting on a per machine basis within your infrastructure. You can say the Windows machine needs 4 gigs and the Linux machines need less.
It depends what you're running.
Yeah.
So if you have a full Windows server with the GUI, then probably you need more than a Linux box to do some changes.
Okay, so let's flip back to these slides and just kind of recap some of this. So these slides will obviously be made available, so you have the links in. So obviously for Test Kitchen to talk to Vagrant, which has the Hyper-V support in, you need to install Vagrant. Test Kitchen, we have a website, kitchen.ci. You need to make sure Hyper-V is enabled, and I mentioned about the default switch, which is I think the mode most people will want to operate in on their environments. The kitchen YAML file is driving the configuration. I would say avoid the temptation to test in parallel if possible. Obviously, if timing is like a thing that's important, then sure, test in parallel, but it's quite hard to read the output because it's just, when you're debugging this and looking at a CI server in retrospect, being able to identify from a log file which isn't in color is quite difficult. You can find Hyper-V boxes on the Vagrant site, or you can build your own using Packer. And then there are other drivers. So we used driver Vagrant. There's drivers for Azure. So I built that one. And in using the Azure driver, you can specify the URI for the URN for an image. So one thing we frequently do is sort of say, okay, we're running against these images that get published nightly, and we can test against the nightly builds that the Linux providers are publishing up into Azure, which is quite a useful thing. If you're an ISV like us who build tools for these platforms and hope that they run every day. Which brings us on to the other types of drivers and provisioners, which Gael is going to talk about.
So another one on that slide. So you can use, as you said, you can use Vagrant. I can see you've got Docker in there. The Windows, I suppose, is for Hyper-V. And then there's vSphere. So I've used it on vSphere environment. And there's many more.
Yep.
AWS.
We've got drivers for pretty much all the major cloud providers, and then there's like OpenStack providers and so on.
So that is the platform. And then the second layer you can see is he's using Chef, and that's the demo that you had. And I know someone here is using SaltStack, to do the same thing. And personally, I use DSC and Pester to use it and to do my DSC configurations. So everything you've seen so far, it's exactly the same principle, just a different language. And this is most of the time we say, well, it doesn't really matter which configuration management tool you're using, it's about the concept. And this is the tool that really shows that no matter what tools you're using, the principle is actually supported with that tool. which is about your development workflow and your validation within your CI pipeline. So I'm going to jump in there. Because I can't type, I actually, oh, no, actually it's next, sorry. Because I can't type, I created a video. And I'm going to try to go through. So very similar to what you've seen, I'm actually doing the same thing. I do a list. I have only one VM, try to keep it simple. Sorry, one test case, which is one VM here. This is the name. It's a Win 2016 with an update on WMF5. I run the same type of command, so kitchen create, and this is my Hyper-V. I'm not using Vagrant, it's just plain Hyper-V. I show you I already had a VM, that's why I showed you things, but this one is turned off. That was the image I created manually, not using Packer. And, yes, I should. And this is just creating the VM. And what it's doing is spinning up the VM. It actually creates a differential disk with my base image, which I'm going to show you in the YAML file. And then it starts the VM, and it waits for WinRM to respond. So you can see it says created, you can see it's running, and if you look at the screen here, you have the login screen, and then the network stacking is being ready, and then Test Kitchen is just pulling to make sure that the WinRM is able to connect. And this is done, and you can see WinRM established. And then it finishes and say, okay, I'm ready. So I have a VM set up. And now, just to show you a command we didn't show you, but I've heard people finding this very useful. So I'll just go on the machine directly and RDP, enable RDP, because I usually don't do it, but some people find it useful. So I'm just trying to go a bit faster on that bit. So just the usual thing. So a note on this, I created this image, which is a plain 2016. There's no customization, and by default, in 2016, not 2012 R2, WinRM is enabled, so you can use it pretty much out of the box. I just did an install. I set up one account, the password for the administrator account, and that's all I've done. So here, manually, just to show you one command, I enable RDP, and then I can use kitchen login. Close this. I type kitchen login, and that's automatically going to open MSTSC with that IP. So kitchen login, and I will have the prompt for remote desktop services, or remote desktop connection, sorry. And I ask for the passwords. You can see it's using the IP, which is automatically found. I never touch the IP. This is dynamically from the Hyper-V, assigned by Hyper-V. I just go here, and you see I'm getting logged in. So when you do development, sometimes it's convenient when you want to troubleshoot what's going on, or you want to make sure that your test is failing, why it's failing, you want to debug, you have something local you can work with.
So I should say, just at the end of the kitchen create process, the IP for the machine actually gets stored in a state file.
Yeah, I'll show it later.
That's in your .kitchen folder.
Yes. So after that, as we've seen, we're going to do a converge. So kitchen converge, as I say, is going to take the configuration that I've written, and then from that configuration is going to converge it. Question?
I've read that you can also do after create scripts, like create done, it runs the script, and then it says complete.
Sorry, I'm not sure I follow.
So you did kitchen create,
Yeah.
and then the last step in the create phase runs the script.
There's many ways to do it. You're talking about the hooks?
That is driver specific. So some drivers provide a capability to read more config out of the YAML file and then execute more commands afterwards. But the create within the driver itself is purely concerned with creating one instance of one machine ready for test.
But if you want to run scripts like this, there's a very easy workaround, which is using unattend, which is what I do usually. When I need to have a very clean image, like literally like you just installed it, I just sysprep the image, and when I spin it up, I load boot media with it, and within that boot media, I have unattend.xml, and then I can have a run once or whatever scripts in there, and then I can spin it up and do whatever I want. So that's one way to do it as well. I have a blog post about using Test Kitchen, and I think there's a link later on, and I explained how to create an image, and there's another one which is how to use Test Kitchen and what is the development workflow. So we're running the configuration. This is a DSC configuration being applied, and you see this is the DSC configuration output. It's a very simple configuration. Just for the example, the code is going to be is available in GitHub. And this is running the kitchen verify, have you seen? I am just showing you, this is the output, which is from the remote machine, from the VM, and you can see this is DSC being run. And after that, I struggle a bit with the scrolling, and then I do a kitchen verify, which is running the pester test to make sure that what I've done with my DSC resource is actually what I expect. So it's just running pester, and very simple pester test I'm going to show you. So this is the workflow that you tend to do. So again, same way, you do run the kitchen destroy, you see that the 2 test passes, plus, otherwise it would fail, and I'm going to show you when it fails a bit later. And then you destroy, so you want to remove the VM because you want to iterate over and over again. So that's the kind of things, when I develop DSC configurations, I probably spin up 10 or 20 a day. So the quicker it is, the best. You see they disappeared. That one is the one turned off that I had at the beginning. So if you run a kitchen test, that's why I said you do the create, converge, verify, destroy at once. So you don't have to type each of the commands. And when you're pretty sure it's going to work, it's more to validate what you're doing, you tend to run this. And then it's going to clean if anything's left. And it's going to start the VM, create a VM, converge the VM, verify, you're running the pester test, and destroy it for you. If everything passes, you have nothing left, and you can start again whenever you want. If there's a failure, and you don't specify destroy every time, it will stop wherever it fails, whether it's the converge, if you have a problem with your compilation of your configuration, or when you run the pester test. And this is the YAML definition for Hyper-V, so I'm not using Vagrant, I'm only using Hyper-V for the driver. And I just specify which VHDX I need to use and which path it is in. And there's some other options if you want static address, specific DNS server, and this is specific to the driver. As you can see, the transport is WinRM, and I just pass the administrator password there so everyone can see it. But technically, there's other ways you can manage that. And this is the provisioner. So in that case, it's DSC. The provisioner has been written and maintained by Steve Murawski, which used to be at Chef and now working at Microsoft. And he's also written the verifier, which is pester. And he actually just looks for a folder, and then he appends the test to it. So in my case, I just use the default, and it's going to run this. And you can override into the other things. So, sorry. So this is a look at the DSC configurations I was using. It's very, very basic, very simple. And I just use the script resource to show the principle of DSC, where you have a get, test, and set. And I have 2 of the script resources. This is the second one. And I just run this, and I do some get and test and set. And I will show you in a second the test that actually matches those. So in this case, the pester test just makes sure that the file exists. Pretty simple. So the configuration when I do a converge creates those files, and when I run the test, I make sure they exist. And as you can see, this is a different environment, a different session, but because Test Kitchen stores the state in that folder, in this folder actually, the .kitchen, then it can resume for different sessions. And it keeps, and I'm going to show you in a second, it actually keeps the ID of the VM to make sure that it doesn't create a new one or it doesn't override it. So this is the content of the kitchen folder, and you can see you have the GUID of the VM, and you've got some other information, and you have the last action as well, so you can resume from the last state, or you can try to. So, pick that one up. So another example, which is using a very similar resource, but this one is using the file resource, and I'm going to show you a bit of the workflow when I develop, is you've heard before Bartek said, never trust a test that never fails. So let's first write the test, see it fail, and then try to make the configuration converge to that state. So it's like BDD, where you try to, or TDD if you want, where you try to write the test first and then converge to that state. So this is very similar, but a bit cleaned up YAML file. You can see I'm using the same VM, with the same VHD, so creating a new VM every time. And this is just a test file. So there's already one, and there's already the test for that one. So now I want to create a new file. And I want to test that the new file exists. I'll just copy-paste my test, just because I want to reuse, and I could give it another name, and I give it also another content. You'll see, I write the test first, and the test says, if I can find another test file in the root, then it's fine. And then I also, no, I don't check the content on that one. So now I'm gonna run the test here. So kitchen test. That runs the full suite until it actually stops, remember? So it's gonna start the create. It cleans up everything that's done before. It starts the creation. And it's gonna create the VM. I think I speed it up a bit, just so that we can fit a bit more. I think no, that one is real time. So that gives you an idea how long it takes. This is why the quicker you do it, the quicker it is, the quicker you get the feedback. So the quicker it fails, the smaller changes you can do at once. That's why when you do 20 machines a day, you can spin up very quickly. It's very quick feedback. If you had to wait for an Azure VM to spin up for 40 minutes, then you have to wait 40 minutes to actually get the result of what's running. And you can see this actually failed and tells you the verify failed an instance. Blah. And you're going to see exactly what happened. The problem is one of the tests I just created, it failed. And you can see this is the test output, and it tells you and the test file should exist in C. So, all right, now I have a failing test, I can make it go green. So I'm going to go and change the DSC configuration. I'm going to try to create a new file. And if you're not familiar with DSC, I create the same file, and you see it's got the same resource name, which is wrong. But I do create the right name here, and I change as well the content. But if you try to compile them off, that will fail. And this is what's going to happen. Hey, you should come back in 2019. So I converge again. Actually, I rerun the full test, so it's going to clean up. Oh no, do I converge? Yeah, I converge. Yeah, I couldn't remember, sorry. So I converge again, and that's going to take this new version, push it to the machine, try to compile on the machine, and try to apply the configuration. And then you see there's an issue in the converge. It's not even the test, the converge says, well, something's wrong. So I know what's wrong, I'm just fixing this, I'll just call it 2, and I try again. So you can fail very quickly and at virtually no cost, because that took me 1 minute to find my error. If you have to wait for a long time to compile on your CI server, running a VM in Azure, the delay of information is sometimes a bit of a pain, unless you want to go for lunch and then you come back and, oh, it failed, I need to try again. The converge this time worked, so we can run the verify to make sure that this actually does what I believe it did. And we'll see the results of the pester test. And then the test worked, and I can finally just get rid of my VM. Make sense? Question? Do you like it? Yes. Kitchen rocks. So not many people know about Test Kitchen usually, but I found that I wouldn't be able to work on so many configurations if I wouldn't have a tool like this, because you can really iterate quickly. You don't have to create big configurations at once. Now you try spinning up a whole environment. You just do on one machine very specific things. On this, the other thing you can do actually, so in this case I just rerun the full test just to validate everything's fine. When you have a big suite, for instance, that's a good thing to do. So this is using DSC configurations, but if you look at just running scripts in the end, so you can actually just test your modules for integration. So if you have a module that changes your system state, you can just use this to test your module within a VM and destroy it afterwards. The same as you would do in AppVeyor. But you can do that internally very easily. I usually do this as well for my modules when they change the state. I don't want to run that on my workstation. I want to do that on VM, a clean VM every time. Questions? No?
Thank you. That's an awesome use of Kitchen. We'll just sort of move on, but we've got another question over there.
Yeah, just a quick question. When you are testing the DSC, you have a module. Is it easy to
Yes. I showed you just the configuration, and actually the provisioner, so the DSC provisioner has two modes that Steve created. One is the configuration mode, and the other one is the module mode. And actually, it depends on how you lay out, but if you have a PSD1 and a PSM1, it will see, oh, this is a module, so it's going to take the module and install the module automatically. You have nothing to do. So actually, if you look at my blog post, there's an article that points you to the right direction with the two type of layout. The change is not in the configuration, it's just the way you lay out. So if you do your .kitchen.yaml within your module, it knows automatically that it's a module and it's going to install that module for you.
Can kitchen talk to Untitled VM via KVP exchange interface?
That depends on the driver, and I don't think the driver would support something like this.
Can it talk to?
Can kitchen talk to a VM via KVP exchange interface? Not via WinRAM or virtualization, but via KVP.
Transport.
So there are various transports that can be used. We have not I've not seen anyone develop a transport like that, but we'd love a contribution if there are people out there who would find that useful, then yeah, we would definitely integrate it. Our transports and drivers are fairly fixed. You can do things like there are workarounds that you can do, like use a proxy driver which can execute some commands via the local machine, which can kind of set up your connection, and you can potentially use some kind of tunneling over between machines that way. We've seen lots of tricks that people can do. It's fairly flexible, as you can see. Like if we can swap in Chef provisioners for different types of provisioners, different transports, then yeah, we can do most things.
So in your case, imagine you want to write the transport for this. You have to write just one transport, and you can reuse every other driver or the provisioners or some of the things. So you just have to write that layer, and you can reuse all the other layers. That's the way Test Kitchen is designed.
Yeah, it's all additive.
Yeah. More questions? Is there a way to connect?
So you would organize that into different suites. So different permutations of suites can have different lists of tests that are executed within the...
I think you meant a multi-node test across nodes? Yeah, so the question was, can you connect one test from a VM to another test to another VM? And I believe your use case is by using multi-node type of test. Natively, no. But in theory, you're just spinning up VMs. So as long as they can communicate together, you can have things that run. But that means you have to wrap around to some extent to make sure that you have an environment that can talk to one another.
Yeah, we don't have explicit kind of workstation to multi-node test capability and reporting within Test Kitchen. But if you think of it kind of logically, the node that you bring up is the node that you are testing from, and that will provide you the results. So if you can write your tests in a way that then can collect results and return a single set of results to Test Kitchen, then you can do it that way. We've seen some people do that.
Yeah, as an example, I used to wrap it around, and I had a test which was spinning up a pool server, spinning up another VM, and my test was making sure that the VM registered to the pool server, and then they could communicate and converge, and then tear down when I was finished. So I know it's possible because I've done it. It's a bit it's a bit of manual work when you need to say, well, you need to spin up this 2 VM, and I used different test routes, and the test routes were waiting for the other one. So it's possible, yes. I should write a blog post about that one.
You should write another blog post.
Yes. Yes. You saying that.
I'm going to add it to the end of this. I didn't put it in, so I'm going to change the deck and make sure it's uploaded so that you can get it.
Yeah. Good.
Any other questions? Okay, thank you very much for coming.
Thank you. That's all right. Good one.